Hello everyone. We're going to be going through some polynomial functions today. I know you're super excited, so we're just going to get straight to it. So, polynomial functions, the first thing we need to talk about is the degree of a polynomial function. This is the highest power x is raised to. All polynomial functions have a number of roots that is equal to the degree. So a quadratic function has the highest exponent is 2, so it will always have 2 roots. Now sometimes they're imaginary, sometimes they're equal roots, like it ends up to be the same thing, but there's always going to be 2 of them. So on your calculator, you want to look at the graph of f of x equals x to the fourth minus 10x squared plus 9. So I know you don't have a graphing calculator at home, so I'm going to pull one up here. So I'm going to go ahead and graph y1 equals x, I'm going to use the caret to the fourth power, minus 10x squared plus 9. And I'm going to hit graph on that. And it gives you something like this. Now you'll notice that there are 1, 2, 3, 4 zeros on this. So we can calculate the zeros just like we can calculate a max or a min. So you want to go ahead and push second, trace, which is the calculate button, and you'll notice that your second choice here, right here, is a 0. So we want to calculate a 0, so hit enter. And you have to find your little spider. Here he comes down, and we're going to start with the first one. So we want to go above somewhere, and that jumped off the graph, but we know because that was below, so the next one has to be above. So I'm going to hit enter for my left bound. I'm going to push to the right. Now I'm below that 0, so that's my right bound. Enter. And of course I want to guess. So it'll calculate for a second, and you'll see that our first 0 is at -3. So 0 is at -3. You can do the same thing for the second one. You want a second trace again, pick a 0, move so you're just to the bottom of it. So we're just to the left. Doesn't matter where you are. I'm going to pick here. I'm going to go above it for my next one. And then I want to guess again. You'll notice that our second 0 is at -1. Our 0 is at -1. You're going to do the same thing for the third one. It's the same process over and over, you'll notice. So I want to go ahead and go above that. And you're fine. Don't worry. Come on in, Miss Smallwood. Say hi to everybody.
Hi, everybody.
That's Miss Smallwood for you. So we're going to make sure that we are above here for our left bound. We're going to go below it, and it doesn't matter, again, where you are. For our right bound, hit enter and guess. So our third root is going to be at 1. And for the last one, I'm going to do the same thing. Second trace, pick 0. And I'm going to show you, it doesn't matter if I move from here. I am somewhere to the left of my 0, so I'm going to hit enter. I'm going to go all the way over so that I jump up above it and hit enter again. And when I guess, even though I was really far away, it still tells you that the next 0 is at 3. So, what the graph kind of looks like here, it's something like this, and then it comes down, up again. Okay, so that's how you would solve something graphically. Now that doesn't always work because it gives you some crazy numbers, and a lot of times if it's imaginary, it won't find anything. So we are going to have to solve some things algebraically. So you have to think all the way back to chapter 1 now. If we want to solve this polynomial algebraically, we need to factor it, just like everything else. So when you factor, you want to do this by parts. So for this first set here, you can take out an x squared, and you'll be left with x minus 2. For the second part here, for this, you can pull out a 9. Oops, a positive 9. And you'll be left with x minus 2 again. So now we have, as we continue down, we're going to have, get a color that works here, x squared plus 9 is the first thing, and the second thing is x minus 2. And we can go ahead and factor t-bar that. This is not the difference of two perfect squares. There's a plus in the middle, so you can't factor that anymore. You're going to have x squared plus 9 equals 0, and x minus 2 equals 0. So you're going to subtract 9 here, and you'll have x squared equals negative 9. When we take the square root of that, we're going to have x equals positive or negative. There's a plus or minus now, and the square root of negative 9 is 3i. Over here, we're going to subtract 2, and we'll end up with x equals negative 2. So you'll notice there are 2 roots here and 1 root here, which gives us a total of 3, which is the same as the degree that we had up here, x to the third power. So there should be 3 roots. There's positive 3i, negative 3i, and negative 2. The next example. For all of these, the very first thing you want to do is go ahead and get them equal to 0. So for this one, you're going to subtract, we're going to subtract 13x squared and add 36. So you're going to end up with x to the fourth minus 13x squared plus 36 equals 0. Now, factoring this might seem a little more difficult, but it's actually not. We're going to have our two sets of parentheses. X to the fourth, if you're breaking that up into two things that multiply to get it, you're going to have x squared and x squared. For 36, we need to figure out two things that multiply together to get that add or subtract to give you 13. Well, the factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, 6 doesn't work, 6 and 6, and then you're back up to 6, you already have that. So a set that equals to 13 would be 4 and 9. So we're going to have our 4 and our 9. This negative over here tells us we want them both to be minuses. And now we can break that down a little more. Both of these, in fact, are difference of two perfect squares. So this is going to be x plus 2, x minus 2, x plus 3, x minus 3. And you can do some crazy t-barring there, and you'll end up with x equals negative 2, x equals positive 2, x equals negative 3, and x equals positive 3. Which again, you'll notice that's 1, 2, 3, 4 roots, which back up at the top, that is the same as the degree we had there. 4 roots for a quartic problem. Example 4. Again, you need to go all the way back to the first unit. In this case, you'll notice that there's a t here, a t here, and a t here. So we can pull one of them out in front, and we'll be left with t to the fourth minus 10t squared plus 21. That t to the fourth inside there, we're going to have to break that down a little bit. We still have our t on the outside. T to the fourth can be broken into t squared and t squared. Factors of 21 are 1 and 21. 2 doesn't work. 3 and 7. 4 doesn't work. 5 doesn't work. 6 doesn't work. And we are back to 7 there. So the set of those that can get you to 10 is going to be 3 and 7. So we're going to have a 3 and we're going to have a 7. This minus here tells us we want them to both be negatives. So minus 3 minus 7. And there is nothing you can do to factor that down anymore, so you just want to go ahead and t-bar it. There's going to be 3 t-bars here. The first one is going to tell you that t equals 0. The second one tells you that t squared minus 3 equals 0. And the third one tells you that t squared minus 7 equals 0. So t squared equals 3 for this. Take the square root of both sides, and you'll end up with t equals plus or minus the square root of 3. My t-bar didn't go far enough down there. If we add 7 to both of these, we'll end up with t squared equals 7. Sorry, I should write plus 7 plus 7. I should have written that for the 3 also, but I didn't. I skipped a step. I apologize. And then we take the square root here, so we'll end up with t equals plus or minus the square root of 7. Now those are radicals. You can't do anything about it because they're already in simplest form. But you will notice, one more time I'll point out, there's 1 here, a plus and a minus gives you 2 and 3 here, and on the last one, a plus and a minus gives you 4 and 5. So there are 5 roots altogether, which back up in the problem was what our degree was. The last problem we have right here is x to the 4th minus 5x squared plus x minus 2 equals 0. Well, is there anything we can pull out of those? Well, the last term there does not have an x on it, so we can't pull an x out. And the first term doesn't have a number with it, so we can't pull a number out. So there's nothing you can factor out. The quadratic formula only works when you have an a, b, and a c. Well, our a would be negative 5. Our b would be a 1, and our c would be 2, but we still have that x to the 4th out in front. So what can we do here? Well, can we factor by parts? If we pull an x squared out here, you're going to have x squared minus 5. If you can't pull anything out of that, so it would just be plus 1, and then you'd have x plus 2. These two pieces here do not match up, so you can't do that. Okay, so you can't factor by parts. The quadratic formula doesn't work. Just straight factoring doesn't work. So we're running out of options. This is actually a problem where you would have to solve graphically. With your calculator. Okay, I know you don't have those at home, so don't worry about it today. We will practice it a little more in class tomorrow. You'll notice that this goes back a lot to Chapter 1, which is why we did that in the beginning of the year. You need to be extremely proficient at factoring and doing those other forms to solve quadratic equations and now other polynomial equations. I hope you have a wonderful evening. I will see you in class tomorrow. Have a great night.